the ground surface filled with water, and water is seeped to improve the soil moisture in the root zone. So these are subsurface irrigation methods. Next is pressurized irrigation method, which we need to start today. And there are two methods, sprinkler and drip irrigation method. So in surface, we learned three water application methods. Border, depends which type of topographic situation we are developing border irrigation application for the cropped area. It may be labeled if slope is having cross as well, then it will change to corrugated maybe, and sometimes it's a contour borders we are using. Second, it was basin. It's a rectangular basin or maybe a circular basin for trees like orchards condition, and water is applied to a certain area. And then it is furrow, for which you solve this problem, furrow. So all these three methods, surface irrigation method, have their advantages and disadvantages. We discussed a little bit, and if you are thinking or going through once again the material I am going to put there, you have learned in the class, we can find out which method may be suitable based on the soil condition, which type of soil it is, what is the topographic condition, slope, and which crop basically we are targeting. Then we need to design itself. If you recall, it's a matter of how long border it should be, what size of, if it is basin, what size of basin it should be, and if it is furrow, length of the furrow we need to decide based on the soil first. Then the crop, it should be a particular crop for which we are thinking which method may be suitable, like close space growing, like wheat simply. We cannot have furrow irrigation method, but for sugarcane, jute, these are the crops where furrow irrigation method is better because there is a ridge, wide ridge, 2-3 plants are there, say sugarcane, and we are applying water in furrows so that water is improved in root zone of the crop. So in this way we can decide which particular irrigation method it should be based on the crop, based on the soil, based on the topography, and also sometimes the quality of irrigation water. Now, after surface irrigation method, subsurface, you have some better idea, and then it is pressurized irrigation system where we are applying water with more precision. And let me share you, this is the part 2 I have put here, pressurized irrigation, application of irrigation water, that is in pressurized form. So pressurized irrigation method, can you see the slide? It is sharing clearly? Okay.
Yes, sir.
So it's a pressurized irrigation method. So what is pressurized irrigation method? This is basically method or irrigation method that deliver water as per requirement at high field capacity. If you recall, we learned water storage efficiency, then conveyance efficiency, then application in the field, then soil moisture improvement efficiency, and so on. So number of efficiencies are involved. Like the last problem you solve, you find something, you told 11.57 near about centimeter of water. That is, in that particular problem or previous one problem, we overlooked the efficiency at different stages in supplying water to irrigate the crop. However, if we are putting efficiency in combined, say starting from conveyance to application just 2, it may not be more than say 80% at each stage. So if you are Multiplying these two, it will be near about 0.64. And if you are dividing this, it will go more than 15 centimeter of water. So the difference between these two is basically the loss of water in terms of efficiency of irrigation method. And that's why in the areas where water is less in amount or availability of water is short, we cannot go for such kind of irrigation method where there are loss of water huge, or there is huge loss of water. So it could be better if we have saving of water with high application efficiency rates, so that it can be covered more area, or we can cover more area as irrigation supply system to get better benefit out of agricultural production activities. So irrigation method, we can say pressurized irrigation method, is delivering water as per the requirement by the crop at high field efficiency. This is the basic idea why we are putting a pressurized irrigation system, and it is applying to the plant, individual plant like in orchard or maybe in a crop, and thus in this way overcoming the ill effects of conventional flood irrigation method or surface irrigation method, we can say. So there are two methods, sprinkler irrigation and drip irrigation, or it is also called micro irrigation method. This is sprinkler irrigation method, just for a view to you. It's basically what is characteristic. It's a saving of water and high crop yield in this sprinkler irrigation as compared to surface irrigation method. We have learned border, basin and furrow, or etc. means it is flooded irrigation, subsurface even irrigation you can put here, and it is well suited to water scarce, where less water availability in the areas, and undulating topography. If you recall, all these three methods are not suitable for undulating or rolling topography. Reason being, we need to level the land first, and then only we can design border basin or furrow irrigation method. Along with huge losses, means less efficiency of water application in the field. So sprinkler irrigation, that is the first in pressurized irrigation system, is more suitable to undulating topography. We need not to level the land, and in the areas where there is less availability of water, it is more suitable. How it works? It's simply a source of water. We have a pump usually to lift the water from the source. It could be a surface water source, maybe a canal, maybe a pond, or any other source of water. So we use a pump to lift the water. We have a delivery pipe, and then sprinklers are connected to this supply water, and they are applying water in simple idea. And sprinklers are fitted to a riser pipe from the pipeline which is supplying water here. Riser pipe at a certain height are fitted with the sprinklers, so that they are spraying water, or say simply in the form of raindrops or droplets, water is applied in the field. Now, sprinkler irrigation system is composed of basically a network of pipes and sprinklers in this way. For general understanding, it is pipes which are supplying water, and sprinklers which are basically playing role in water application over the crop or to the plants. Pipes supplying water to sprinkler at appropriate pressure or at an appropriate pressure, varying from 0.5 to 10 kg per centimeter square pressure. And the smaller pressure, that is 0.5, sprinklers which are operated called micro sprinklers, and the sprinklers which are operated at high pressure, maybe suppose 10 kg per centimeter square, these are called the giant nozzle sprinklers. Or say simply, there is one term, it is called rain gun. So it is covering quite large area. maybe near about 90 to 100 meter. So this is the basic idea how or what pressure, under what pressure condition sprinklers are working. In this particular condition, there is a nozzle which discharges water. So before that it is pipe system, water is coming in a high pressure, and from this nozzle this pressure energy or pressure head is simply converted to velocity head, so that it is coming with a high velocity which is covering a large distance. And in this velocity head condition, once water is coming out, it is broken in droplets. So pressure head is converted to velocity head at the nozzle of a sprinkler, and water comes out as jet of water which breaks down into drops when it is coming in the air from the nozzle. Now, the wetted area of a sprinkler depends on how much area it will cover. In simple idea, if you ask, so it depends on velocity head given to the water jet. What is the velocity? If it is high velocity, it will go high, or say larger distance it will cover. What is the angle? If you recall, if you are throwing a particular object in a certain angle, it will cover or it will go to a maximum distance. So that is angle of flow of jet. That is important. And type of sprinkler and its design. There are different types of sprinkler. This is one we are talking, but there are pop-ups which are just spraying near about, and they have a very fixed range. Very rough way of sprinkling water. If you have seen, there is perforated pipe. Once water is coming with pressure, it is coming as a jet covering nearby area up to a certain distance or width. So that is which type of sprinkler it is used and what design it has been used. It depends in area coverage. And most important natural condition is wind condition, wind direction and its velocity. So if it is high wind in this way, certainly water will be drifted to this side. So in this side, it will cover more. However, if it is coming to this side, it will be a less distance which is covered. So these are the conditions. Wetted perimeter or wetted area of a sprinkler is affected. Now, its adaptability to which type of crop, which type of soil. So sprinkler irrigation is suitable to almost all soil types, crops and topographical condition. Almost, but not all. So these are the exception. Crops we cannot cover, say simply rice and jute. Rice requires flooded system of irrigation. So there is no use of sprinkling water because it's more precise. If we are using a sprinkler to flood the field, it is loss of energy. So it is not suitable for rice crop and jute as well. Reason being, it is as well a kind of water loving crop. So need not to sprinkle water here. It's better to flood the area. And these crops are grown in areas where there is more water or sufficient water. What about the soil condition? Sprinkler irrigation is not suitable because it's exception to heavy clay soils. Heavy clay soils, what is characteristic? It's a low infiltration rate. So if it is sprinkled water in heavy soils, infiltration rate will be too slow, much slow than the sprinkling rate. And if we are sprinkling, our rate of application of water in sprinkler system is much less. So droplet already will be very small and it will be more evaporation loss from the area rather than benefit of irrigation. So soil with heavy clay content having basically are characterized as very low infiltration rates are not suitable for sprinkler irrigation. So this is the adaptability constraints of sprinkler irrigation system. There are some advantages as well. So what are those? Extensive field surface channels are not necessary in this condition. We are supplying water through pipeline or through pipe network and putting a sprinkler on these pipelines, on the pipeline. So there is no need of developing channels in the field. Just like bunds are small ridges in border irrigation. In basin as well we have bunds. In furrow we have certain area which is supplying water. So there is no loss of area in that sense if we are adopting or it is adopted sprinkler irrigation. So extensive field surface channels are not necessary in this particular method. Substantial saving of labor in irrigation application, because once we are using surface method of irrigation, we need to develop these reaches, channels, furrows, and so on. So for developing those, certainly we need energy and we need labor. And at the time of water application, we need to guide the water to go at the right place in suitable time. So there is requirement of labor, but in a sprinkler irrigation or pressurized irrigation system, it is not required any labor once it is installed. It's adaptive to all topographic conditions, that is advantage, without expensive land preparation or leveling. Means no matter it is rolling topography or undulating topography, we can go for using sprinkler irrigation, but any of other surface method cannot be used until it is leveled. High water application and distribution efficiency, because there are less chances of water losses in conveyance system or in water application system. Water is reaching to a high uniformity or with a high uniformity everywhere in the area. So at a particular time, everywhere same amount, almost same amount of water is applied in the field. So it's a better distribution efficiency as well as application efficiency in the field. Along with this sprinkled water or sprinkler irrigation water, we can apply soluble fertilizers or fertilizers which are soluble in water, and chemicals if we need to apply to the crop. So soluble fertilizer and chemicals can be applied with irrigation water economically. But in surface method, it is applied by using a lever. So this is advantage as well. So these are benefits of using a sprinkler irrigation system. Certainly once there are advantages, there must be some limitations or disadvantages. So what are those? Bends. So bend distorts a sprinkler pattern, just like you will see later on. If it is applying in this particular area and bend is here, so it will distort. This will cover in this side more area rather than this side. So bend distorts a sprinkler pattern and causes uneven distribution of water. Sometimes in particular, say fruit crops, it is not advised to bed the fruit itself, otherwise the quality will get deteriorated. So in that sense, ripening fruits must be protected from spray or from the water contact, and there it is a limitation. Water must be clean and free from sand, debris and heavy amount of salt, because it is going through the pipeline system, so it will disturb or damage the pipeline. If there is sand, there will be abrasion. If debris are there, it will get choked. And if it is salt affected water or salty water, saline water, then it will corrode the pipe from the inside, and that will be creating more loss of energy, or head loss will be more in that system. So it will automatically reduce the pressure of water supply with time in a sprinkler system of irrigation. Another limitation is its high initial cost, high initial investment to set up this pipeline network. Riser pipes and sprinklers fitted on the riser pipe requires a lot of investment. So initial high investment and subsequent high power requirement, because it is operated under a certain pressure varying from 0.5 to maybe 10 kg per centimeter square. It requires power to operate sprinklers during irrigation system. That is one limitation. And in surface irrigation, we need not to use power, only lift it and put the water in conveyance system and it will reach to the field. But efficiency is low, conveyance losses are there. One limitation further to sprinkler irrigation is low application rate in fine textured soil. Heavy clay, if we are increasing the rate of application, infiltration is very low of that soil, so there will be losses of water. So low application rate we need to put if we are using there in fine textured soil, and that will lead to losses due to evaporation and wind drift more than any other soil condition. So these are the limitation of sprinkler irrigation system. Then now, if we have learned what is a sprinkler irrigation in general, what are advantages, disadvantages, then we need to find out what are different types of a sprinkler irrigation system. Those can be used for a specific crop or irrigation purposes. So there are types of sprinkler irrigation on the basis of arrangement of spraying irrigation water. First one is rotating head system, means there is a sprinkler which is fitted on the rise and it is rotating in a circular pattern. So small size nozzles are placed on riser pipes fixed at uniform intervals, means we have pipeline and we have fitted number of sprinklers in this. It rotated through 90-degree to irrigate a rectangular strip, means sometimes it is in such a way, there are another way that it is means going from left side to right side, and in that it is a pattern of rectangular strip, but in rotating head it is pattern of circular area it is covered. Most common device to rotate the sprinkler head is a small hammer activated by the thrust of water itself. You will see later on that there is a jet which is coming out from the nozzle of a sprinkler, hits a kind of hammer arrangement, so it means vibrates both sides of this, that breaks this water jet in droplets. So it is basically activated by the thrust of water striking against a vein connected to it, and that breaks this water jet in droplets so that water is applied uniformly in the form of droplets in this whole area or in this circular area. So first one is rotating head system of a sprinkler irrigation, and second is it is perforated type of system. So perforated type of system, from figure you can see first that it has perforations are very tiny small holes, and once water is coming with pressure, it is coming out water from these perforations in form of small jets covering the area both sides. So perforated type system, it's perforated lateral pipes to distribute water uniformly, and due to low pressure, just about say 0.5 to 2.5 kg per centimeter square, we can use overhead tanks that may be useful to obtain necessary pressure to operate such kind of sprinkling arrangement or sprinkler irrigation. Like an overhead tank is here as sufficient height, maybe suppose 20 feet or 10 meter maybe sometimes. So it is giving near about 1 kg, or you can find out what is the pressure it can generate because of certain condition, and that is necessary pressure to operate water in this perforated application or sprinkler system. Sprays are directed on both sides of the pipe and cover a strip of land somewhere near about 6 to 15 meter. That depends on the pressure condition it is operated. If it is high pressure, jet will go for a longer distance and it will be more wider strip that is covered. Due to high application rate, it is suitable to moderately high infiltration rate soil characteristics. It is not suitable for heavy clay type of soil where infiltration rate is less. So first loss it will be evaporation, and second, because of less infiltration, water will generate a kind of runoff, which is loss of water from the area. So two types, rotating head and perforated type of sprinklers. So rotating head sprinklers, they are arranged in different forms to cover the area of varying size. Maybe an individual farmer, because in India we have individual farmer area, maybe on an average, everyone has on an average near about say 1 acre land or maximum 1 hectare land on an average. Somebody may have 10 or 20 hectares as well, but it is treated as individual plots. So there we can have a very set kind of system which covers say 1 hectare area to apply the water through a sprinkler system of irrigation. But think about say 1 kilometer or 1000 meter by 5000 meter area which is cropped and we need to irrigate. So there must be some arrangement where we are not putting just 1 hectare area covering a sprinkler irrigation system, that is basically fixed set of irrigation, but it's movable or it is a dynamic system which can cover more area with time. So based on the portability, rotating head sprinklers, we are relearning what are different types of sprinklers within a particular condition. So rotating head sprinkler system, basically based on portability, we can port or change the place of water application from one field to another field. So there is portable system, portable main line, it is supplying water, suppose here, that is fixed in these wheels or has a wheel and variable means space change arrangement. So portable main line and laterals and a portable pumping plant. We have a pumping plant from another side or maybe connected from this side here to supply water to this main or through this main to this lateral on which number of sprinklers are attached. And there are wheels to change from one place after it is covering say a certain strip, it is again transferred to new place to cover new strip of water application or irrigation. So this system or these kind of systems, portable systems using mechanical power for moving laterals or of wheel move system. There is a wheel and wheel move system to change the place or location of water application. Semi-portable system, portability is whole system or whole setup. Main, lateral, sprinklers arrangement, pump system, everything is portable. Now it is semi-portable system, similar to portable except pumping plant and location of water source are fixed. So we have a long main line which is attached with this portable sub-main and a sprinkler system arrangement, so that once we are changing the place, main line is long enough to supply water within the field. So pump is set at one particular source point. It is not changing, our source is not changing. Our source of water is fixed along with pumping station, but we have long main line water supply to apply the water through this arrangement, and that is called the semi-portable system. It may be used on more than one field using extended main line and additional pumping plants. Semi-jet system and semi means permanent system. Now it is solid jet, semi-portable system and semi-permanent system. First one was completely portable. Every aspect of this irrigation was portable, means we can place at another location. Semi-portable, we can cover from a fixed source of water to nearby area by means changing the place of sprinkler application condition. And semi-permanent system, portable lateral lines, means main system here it is portable, but permanent main line and sub mains, and water source and pumping plant is fixed. So main line and sub main lines are buried under the soil. Here everything is out, here as well as in previous condition. But in this semi-permanent system, main line and sub main lines are buried. So anywhere this system is reaching, we are connecting to open this hydrant to supply the water to this system. So that is semi-permanent type of system. So these are all rotating head type of sprinkler systems used to apply water in different crop growing condition. Rotating head sprinkler system can also be seen or can be classified or divided in solid jet system. There is enough laterals or there are enough laterals to eliminate their movement. Laterals remain in the field for the crop season, one crop season, and used for crops requiring short and frequent irrigation, just like wheat crop. Then a permanent system comes to a permanent system, which is usually used in Indian condition. Permanently laid mains, sub-mains and laterals, and a water source and pumping plant. All things are permanent arranged. Main, sub-main and laterals are buried and sprinklers are permanently located on the riser, and these are costly and often used to orchards basically. So that is in Indian condition. We are not having any variable system. Reason being, area is small, maybe 1, 2 or maximum say 5 hectares. So need not to change every time the location of main, sub-main, source and sprinkler, but it is fitted to a constant condition and we are taking advantage of irrigation. So that is basically in orchard type of systems, and especially where land holding is relatively small, from say a fraction of hectare to maximum few hectares, not the hundreds of hectares. Now there is another way of using rotating head sprinkler system, that is central pivot system. So it consists of pipeline rotating around a pivot, means you can rotate here in this all field everywhere, and supported by a large number of self-propelled towers. These are self-propelled, we have wheels self-propelled, so they are moving once we are means changing direction from one side, and water is supplied at the pivot point. Here we are supplying water from here pivot point, and flows outward through the pipeline and is distributed through rotating sprinklers. Those are fitted here, just like here. This is basically a kind of rain gun which covers a longer area. Or here we have fitted the sprinklers. These are basically rotating head type of sprinklers arrangement to cover the area through irrigation. It depends on type of soil, water quality and investment condition, and as well as the area we are interested to cover. If it is very small area or it's huge area, that decides which type of sprinkler irrigation system we need to adopt or we need to place in the field. These are the components of a sprinkler irrigation system. We have source of water, we have pump, we have a delivery line, then we have a bypass valve. If pressure is high or there is a problem, it will bypass to the source any water. And if it is everything is fine, it will go to the supply line. In supply line, because previously we discussed that it should be free from any debris, any sand particle. So there is a kind of filter. A screen filter is used to remove any sand particle or soil particle. Those are coming along with water. Then there is a pressure gauge to measure the pressure. What is the operating pressure of this system? Reason being, these sprinklers are working at a certain pressure, minimum pressure requirement. If pressure is low, coverage area will be certainly low, and if it is operated at higher pressure, it will be coverage area more. But there is a designated pressure, cannot be operated more than a certain pressure. If you are increasing further pressure, it will not cover the larger area, but it will get distort this coverage. Reason being, particle size or water particle size will be reduced. It will have more effect of winds, so pattern will change. So any system is designated to operate at a certain pressure, and that's why we have a pressure gauge to measure the pressure in supply system. Then there is a distributory system, means we have this main line, this is sub main line, and then in sub main line we have these riser pipes. These are the riser pipes connected with sub main or laterals, we can as well say main, sub main sometimes, and this is the lateral, and in the lateral we have riser pipe, and on the riser top it is sprinkler which is arranged. So we have for each supply line or sub mains or lateral, we have a control valve. So it depends what is the capacity of this pump in terms of water supply, whether it is supplying water to say certain number of sprinklers, that depends on our design. How many number of sprinklers we can operate in a certain condition of pump size, supply system, and pressure that is available. So we can close or open control valve to operate number of sprinklers. So this is the simple arrangement means in view, and partially number of components which are used in setting up the sprinkler system of irrigation. And at the last there is a cap, which is basically the flush cap sometimes, or QRC end cap, so that water is not leaked during the operation, but sometimes if it is required we can open and flush the system. In this, if we have seen, there is a pumping system, there are different arrangements, filter systems, then sprinkler system and pipeline. These are the main, and certainly the accessories in pipeline, valve, bends, teeth, joints, etc. So we need to design this whole system. You have already learned the conveyance system, so you can find out what size of pipe it should be as main line, what should be the pipe size as the sub main line or lateral line, what is the size of riser pipe, and what is the sprinkler nozzle size, so that we can design what could be the rate of water coming out from this sprinklers jet as jet, and in that way we can find out how much amount of water is applied since beginning, and based on that we need to decide the pipe size and then pump size. So this is basically the pumping set. That is the first step. We are trying to understand what is the use and how it should be decided, that what size of pump it is required. So what is the purpose of pump or pumping set? Lift water from source and pushes it to the distribution system and sprinklers. So any type of pump, volute centrifugal pump, you will learn later, deep well turbine pumps and submersible pumps can be used to supply water in the sprinkler system of irrigation with required pressure. Centrifugal pumps are preferred when source of water is, say, simply an open well, river, canal or pond, or surface water sources. If we are using centrifugal pumps, could be better because they are easy to arrange and easy to handle. It comes pipe network, pump set, then pipe network. The pipe network consists of main line, sub main line, so mains, sub mains and laterals. Pipes are there. That is pipe network for a sprinkler irrigation system. So main line conveys water from the source and distributes it to the sub mains. So it's the main line, then there are number of maybe sub main lines. And sub mains convey water to the laterals. Now we can have lateral in both sides to cover this area, right? So sub main convey water to the laterals, which in turn supply water to the sprinkler. And in all these sub mains we have put the riser pipe at equal distance and sprinklers on this riser pipes. So supply mains or sub mains convey water to the laterals, which in turn supply water to the sprinklers. So what type of pipes we can use? So aluminum or PVC or maybe SDP, high density polyethylene pipes are generally used for portable system of sprinkler irrigation, while steel pipes are usually used for center pivot system laterals, where pipes are buried, main line is buried underground and it is supplying to a pivot system through a flexible connection to the sub-main or lateral. Asbestos, cement or PVC and wrapped steel pipes are also used for buried lateral and main lines. Once it is buried, we can even use a cement pipe. Reason being, we need not to change the location. So buried system of any pipe which is supporting the pressurized supply of water up to say 10 or maybe 15 kg per centimeter square kind of pressure can support, we can use as buried supply of water pipeline. So that is pipe network for the sprinkler irrigation system. What about the main line and pipe network? The steel pipes or steel pipe is mainly used for permanent main lines. If it is buried, permanent, no flexibility is required, then we can use steel pipes or cast iron pipes to supply the water. Asbestos, cement and PVC pipes are also used because they are buried and this is permanent line system. Lightweight aluminum pipes with quick couplers means we can join two pipes immediately. Quick couplers are used for most portable main lines. If it is portable, then we can use sometimes aluminum pipes. Water is taken from mains through a valve that is placed at each junction with lateral. You have seen this, just like here we have a valve because it's controlling the supply as per our requirement and availability of pressure in line to operate the number of sprinklers. So once it's a main, what about the lateral line? These are usually portable. Buried laterals are used in orchards and tree nurseries where we need not to change the system with time. It is not for just one season, but it is for longer time. So quick couplers or quick coupled aluminum pipe is best for most portable laterals. Reason being, they are buried and they are not getting disturbed with time. They are for longer duration laid there to supply the water for sprinkler irrigation. Now sprinkler head. You have learned main, this is pump, then it is main line, then it is secondary line, number of secondary lines are connected with main, and from this sub main we have number of laterals which are covering the area. And then in laterals we have riser and sprinkler system or fitted sprinklers. So sprinkler heads are basically sprinklers. Two types you have already learned. Revolving head sprinklers, one or more nozzles may be there, and perforated pipes. So most agricultural sprinklers are of slow rotation type, rotating or revolving head sprinklers. But rotation is slow. Its rate of rotation is slow. It is not like very fast. It's a combination of rotation and pressure that leads to the distance up to which water jet is thrown. Basically, it's a rotation and it's a pressure that is water coming to this system that covers the area of irrigation. So sprinkler heads most commonly used have two nozzles. Revolving head sprinklers most commonly have two nozzles, one to apply water at a considerable distance from the sprinkler, just like here, we have two nozzles. One is smaller and one is bigger. So first one is to cover the larger area from the sprinkler and other to cover area near the sprinkler. Means you need to have a kind of uniformity in this area. So once jet is emerged from the nozzle of the sprinkler, it will cover longer distance. So it will go here, then start breaking the stream in droplets. But what about nearby area? So for nearby area, the second nozzle is used to cover the area nearby to this setup or this system. So there are usually two nozzle sprinklers like this. Water is supplied from here, and this is secondary nozzle or spreader nozzle it is called, and this is the main nozzle or drive nozzle are called range nozzle. So it is getting water at high pressure. In the same way, here it is having most of the energy to throw the water to a longer distance. It has a certain trajectory angle to cover the larger area. And this is the impact arm. Basically, it is loaded with a spring, and once emerging jet hits this hammer, what happens because of this spring loaded condition, it just flips left and right, and in that way it is breaking this jet into water droplets which are thrown to a larger distance to cover the farthest area from this sprinkler system. This is spreader nozzle which is covering nearby area to this sprinkler to make the uniformity of this whole area under irrigation. So this is basically two nozzle branch impact kind of sprinkler, impact hammer kind of sprinkler made of, here you can see it's rainbird. Here it is, if you are seeing just in front of you, it has mentioned the size of nozzle opening. So from there, if you recall, we have learned discharge from orifice is equal to CA root 2GH. In orifice, water conveyance as well as in measurement, we have learned that discharge coming from an orifice means water is stored in a tank and you have just a small opening. So it is called as orifice there in water supply system, and orifice plate as well you have learned in pipe flow system, which has a smaller opening than the pipe size. So there we can find out what is the discharge. So that gives us an idea what is the capacity of this sprinkler system. If we know the head of operation H, we know the coefficient of discharge for a particular nozzle or orifice nozzle, we can find out what is the discharge capacity theoretically of this nozzle. So how much is the water application rate in this particular area we can estimate, and we will learn subsequently here. Now it's a two nozzle branch impact hammer type of sprinkler which is used to supply water. Now once you know that it's pump to supply the water, there is main line, there is sub main line, there is lateral pipelines on which risers are fitted along with the sprinkler. We need to think once more just for your understanding. Suppose water has impurity, debris or suspended material. We need to put arrangements to remove such kind of problems. And here it is, suppose say debris are there or water is taken from the say pond. There are water plants which are creating or which are sucked in this main line of water taken by the pump from this pool. So to avoid any choking of this pipeline, we are using a kind of a screen which removes such kind of impurities coming along with water in this pipeline. So it's a debris screen basically. It is needed when surface water is used as source of irrigation, just like from the pond, and this particular debris screen keep the system free of trash that may plug the sprinkler nozzle if it is supplied through this pipeline to the sprinkler system. Then this is one way, debris screen. Then second, it could be desilting basin. If it is surface water, silt is there along with water, we need to have some arrangement of pooling this water in a, say, secondary pond so that it is settled, and that is called the desilting basins. It is required to trap sand or suspended silt in water from the streams, open ditches, or maybe sometimes well as well. Sand is coming, and the capacity should be large enough to provide protection for at least one full day or support for at least one full day. So this desilting basin should be quite bigger in size so that we can supply water for irrigation purpose at least for one day. And then again it is filled to make the continuous supply of water through sprinkler irrigation to the field. So it's a debris screen, then desilting basin. Then we have, say, booster pump. Sometimes we require more power to supply water, and this pump is used as addition to the fitted system. So booster pump used when existing pumping system capacity is insufficient to force water through the sprinklers. Then takeoff valve, control pressure in the laterals. We need to arrange some valves so that pressure is not reduced or one side of supply line is closed to supply water with certain pressure to another side. So takeoff valve controls pressure in laterals, used at locations where pressure at the main line and lateral takeoff point have significant difference. Suppose it's a main line coming and it is sub-main line. If there is sufficient difference of pressure in this and this sub-main, there we use takeoff valve to maintain the pressure and control the supply towards another side. It permits movement of laterals without shutting the entire system. Means we need not to shut the entire system to close the supply another side, but it is simply stop the supply another side to increase the pressure in a certain lateral. Flow control valve to regulate the pressure and discharge of individual sprinkler may be helpful. Flow control means we need to control the flow in one direction or all the directions of supply system. Then fertilizer application unit, or it basically has primarily first filters. So fertilizer application unit and filters basically we use. So fertilizer application unit, soluble chemical fertilizers can be injected into the sprinkler system and applied to the crops. How? Venturi you have already learned. So Venturi, theory of Venturi, it is used to apply the liquid fertilizer. If this is the Venturi with high pressure, if you recall it, right? And once we are reducing the size of this pipe by putting a Venturi here in this section, pressure will reduce here and velocity will increase. So once pressure is reduced, any connection to the suppose a liquid tank with this pipe connection, because of this difference in pressure, it is low pressure. Here we can have a high pressure. It will suck this fluid to the main line, and this is the fertilizer in liquid form. So that is one way to apply liquid fertilizers or soluble chemical fertilizers can be injected into the sprinkler system and applied to the crop. It consists of sealed fertilizer tank. This could be a sealed fertilizer tank with necessary tubing and connections to connect maybe this Venturi. So a Venturi injector is connected with the main line just like here, with which creates the differential pressure to suck fertilizer solution to flow in the main line, and that is one specific condition of liquid fertilizer application to the crop by using sprinkler irrigation system arrangement. However, there must be filters everywhere to filter the suspended solids, to filter any impurity in this air. So there are filters. So filters are used to filter the suspended particles and debris flowing with water. Fitting accessories. Water meter is used to measure the volume of water that is diverted into the system as irrigation application water to the field. It is necessary to operate the system to supply the required quantity of water. So we need to have a water meter. Flange and coupling are used for proper connection to the pump, suction and delivery condition from the pump. Then pressure gauge is used to measure the operating pressure of the sprinkler system, because we need to operate at a certain minimum pressure and should not be more than a certain higher pressure. So bends, T, reducers, elbow, hydrants, butterfly valve, plugs are different types of fittings are involved, or fitting components of the sprinkler system are involved to fit this whole system in the field. So they are used as per requirement. And that create a lot of loss of head of water, head loss, because of pipes, because of fittings. So we need to design the whole system to supply the water with available pump or pressure condition to the crop. So this is design of a sprinkler system. You have another class? Oh, it is.
Yes, sir. We have another class.
Okay, okay. So design of a sprinkler system we will discuss later. Okay? कौन भाई लड़ाई कर रहा है साथ में क्लास के? Okay? Any query? A quick query if you have. Otherwise, you have not given me time when I can take. If you do not have time, then I will take it next week, Monday and Tuesday. Is it okay? Lokesh? Nobody is speaking.
Yes, sir. It's okay.
Okay. Means you do not have time and I need to finish it in Monday and Tuesday next week, right? Do you want to say like this? भाई बोलो तो कुछ.
Sir, we can have it on Saturday, sir. 9 to 11.
9 to 11.
You can have. You have not given me time.
No, sir, we have already discussed. Yeah, we have already discussed it, sir. We want to keep it on Saturday 9 to 11.
Saturday 9 to 11. Okay.
Yes.
So let us meet on Saturday 9 o'clock to finish this pressurized irrigation system, to finish the irrigation part, and then it will be drainage part. Professor Damodar Rao Melapalli will teach you. Okay? So we are going to meet on Saturday 9 to 11. Is it fine?
Yes, sir.
Yes,
Okay,
sir.
perfectly fine
Yes,
to me as well. See you then on Saturday.
Yes, sir.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Welcome.